Okay. Thank you for the invitation.
Yeah, just a minute. I will have a little background. Dr. Krishnan will start, and then I will invite you. Just sorry,
okay.
sorry.
Yeah. Thank you for.
So, can we go live? Padmakar? Thank you. Namaskar ji, esteemed panelists, Director IITM, distinguished delegates and participants. Welcome to this special brainstorming session on soil moisture monitoring in India, challenges and opportunities. We are organizing this special session under the banner of India International Science Festival, that is IISF 2021. This morning, we had very successful session conducted in the regional language Marathi. As it was emphasized in the morning session about this year's theme, that this year's theme, ISF theme, is celebrating creativity in science, technology and innovation for prosperous India. And I think we need to explore better scope for this. Therefore, this session is aimed to promote creativity and innovations for soil moisture monitoring in India. I now invite Dr. R. Krishnan, Director IITM, to make opening remarks. Dr. R. Krishnan.
Thank you, Dr. Milind. First of all, I welcome all the participants of today's brainstorming session on soil moisturing in India, challenges and opportunities. Dear distinguished panelist, Professor Trenton France, Professor Dev Niyogi, Dr. R. Mali, Professor Falke from Agricultural College, Pune, Dr. Premnath Venugopalan from NCL Innovation Park, Professor Chopade from the Pimpri Chinchwad College of Engineering, Sri Santanu Pendarkar and all the participants and colleagues. It's my great pleasure to welcome you all to today's brainstorming session on the soil moisture monitoring in India, challenges and opportunities. The recent IPCC report and also the special report on climate change and land in 2019, it highlighted that climate change has larger impact on land region. The global land temperature has increased by 1.53 degrees since 1900, and compared to the global mean temperature land and ocean, which is about 1.1. And so this rise has occurred due to significant changes in the land surface temperature resulting from soil erosion, desertification, land degradation, etc. Soil moisture is a key climate variable that is important for agriculture and hydrological activities. It is also a key indicator of climate change. Also, soil moisture is a very important parameter for numerical weather prediction and also for initializing the models for sub-seasonal to seasonal scale forecasting. In this connection, I would like, from the climate change context, I would like to highlight the important contribution in climate science by Professor Sukuro Manabe, the winner of the 2021 Nobel Prize in Physics for climate science. So during the 1970s and 1980s, Professor Manabe had developed a very simple model of the soil moisture variations based on the bucket model, and he had demonstrated the significance of soil moisture in land-atmosphere interactions through modulation of the surface fluxes. He also demonstrated the role of soil moisture variations in the evolution of extreme events and hydrometeorological processes. Professor Manabe's work for estimating soil moisture memory timescale beyond its spatial heterogeneity through simple climate model has been one of a major highlighting contributions in climate science. So the recent IPCC report has clearly shown that with future warming, the hydrological cycle is going to intensify, which means that the wet regions are going to get wetter, and the dry regions, many dry regions like the Mediterranean and parts of the US and Australia and many regions in the world are going to get drier, and agricultural and ecological droughts are going to become more severe. So with this background, it's very important to have high resolution observations of soil moisture. At least should be less than at least 5 kilometer grid on sub-daily basis. And this kind of high resolution observations of soil moisture, both in space and time, they are very much needed for weather and climate forecasting and also for hydrometeorological applications. There is also an urgent need for enhancing the observational network for soil moisture. Currently, the Cosmos soil moisture measurements is being undertaken in India at several places in India, and also at IITM Pune by Dr. Milind Majumdar. And this is the main network that has been providing real-time high-frequency soil moisture data at 0.5 by 0.5 square kilometer, that is field scale observations in different parts of the world. So I would like to welcome all of you to today's brainstorming session, so that you can deliberate on these, what are the challenges and opportunities, and make recommendations how to go forward. Thank you all for joining this meeting. Thanks, Bill.
Thank you, Dr. Krishnan, for nicely setting the background for this brainstorming session. Now let me just add a little more in this. At IITM, we are attempting to develop low-cost sensors systems for monitoring soil moisture across India. We see this as a very attractive opportunity, which we would like to explore. And in this regard, we would like to learn more from our esteemed panelists on how we should move in this direction and what would be potential challenges. Your valuable inputs will guide us in better conceptualization and planning in this direction. We also look forward to industry, academia, stakeholders, collaborations. Now, first of all, let me welcome Dr. Trenton France from University of Nebraska, USA. Dr. France has contributed immensely in expanding Cosmos network in USA and other countries as well. He has provided us valuable guidance in advancing soil moisture R&D activities at IITM. He has extensively published his research work on soil moisture. Dr. France, we are keen to hear from your experience and perspectives on this important topic. Dr. France, please.
Thank you very much. Very nice to meet everyone. I know I've been in contact with some of you over the last few years, and very excited to see the network continuing to build across India. So very excited to see those results, as well as combining it with some of the lower cost sensors to be able to scale that up. So yeah, so in terms of challenges and opportunities, I think a big thing is, acquiring the sensors, getting them in the ground, getting them calibrated. I think that's, you guys have done a great job with that, of really starting to master the technique, as well as expanding it into new areas, particularly around, tropical land surface interactions. So very excited to see some of the recent papers that you published, and I would fully agree that the next steps are coupling it with the numerical rainfall runoff models, as well as the larger mesoscale models to look at those land surface feedback. So I think that's one of our biggest challenges in the community is I think we've mastered the technique and calibration, and the next steps are how we integrate that data with numerical models, as well as validating remote sensing products like SMOS and SMAP and Sentinel, and how we can better utilize and combine that with the remote sensing soil moisture products, because that's really the big challenge is how do we scale these few point sensors or field scale sensors across, say an entire region or country to then be a useful input into the numerical weather models. So I know there's been some recent work around data assimilation and how we ingest the data most usefully in these models. So I think that is a clear area of can we actually improve forecast skill and how do we ingest the data in the actual models. So one point there, and then I'll move to the next guest, is that when we do data assimilation, it seems best to assimilate neutron counts. And so there needs to be basically operators or modules that take the numerical weather data of soil moisture and turn that into a neutron count and then directly assimilate that instead, because the distribution of neutron, the error on that is Gaussian error. And so that's much better for the numerical models of having the state variable being a Gaussian product instead of soil moisture, which has kind of a different uncertainty distribution around that. So that is just one point of to assimilate neutron counts directly instead of the soil moisture is a better way to go. So looking forward to the rest of the panelists and providing some useful feedback. So thank you again. I think you're muted.
Yeah. Thank you, Dr. Franz, for enlightening us with your experience. And we would like to, we may have few rounds, and we may like to hear more from you about this networking, particularly the networking. Now I invite Dr. R. Mali, whom we were waiting actually. Dr. Mali, welcome to this panel discussion. And Dr. Krishnan has set a nice background for this session. What Dr. Mali has been retired from scientist. He's retired scientist from India Meteorological Department. Dr. Mali has been involved in surface observations and instrumentation throughout his service of about 4 decades. And currently, Dr. Mali is involved with soil moisture observational network across India. So we would like to hear more from Dr. Mali about the current status of the soil moisture observations across India. Dr. Mali, please.
Thank you, Milim. I'm extremely sorry that I'm late today. There is a meeting going on, and somehow I have to rush for this particular meeting. So I'm extremely sorry for the delay from my side. Having said that, yes, I did work in India Meteorological Department, and well, we have a huge network of surface observatories, classical surface observatories. We have automatic weather stations. We have a radiation network. We have airport meteorological instrumentation network. So it's a huge network, complete installation, maintenance, calibration. All these things was done during the tenure. We have independent workshop also where we used to manufacture these sensors in-house. We do calibrate all this. We have all the test and calibration facilities before they get deployed in the field. We used to calibrate them and certify them, especially for the aviation field, airport meteorological instruments. That includes the transmissometers and ceilometers, etc. Coming back to AWS network, we have started our work in 2009 onwards, this establishing a AWS network. And after that, we have taken a big jump in 2011-12, where we have changed the entire scenario. Earlier, we used to have AWS with a satellite communication, and then we change it to the mobile telemetry systems. And since 2011, we are using those AWS network with mobile telemetry. Now, there we attempted few soil moisture sensors during the tenure, and well, Those sensors we have installed at 128 locations in India. They are basically agriculture field units, and there where these systems were installed. Uh, Various type of sensors we have used. Lot of experiments were done. We had initial hiccups. We had initial problems in installing. Initially, we installed a theta probe and delta T type sensors where we have we used to get soil temperature and soil moisture at two different levels, mainly at 20 centimeters. The soil moisture, and of course at temperature at 5 centimeters and 20 centimeters. After that, we also attempted Steepen Hydra. There is one more company where we used to get moisture, salinity, and temperature. Also a combined probe that also tried in our network. Um, uh, Further, we have used the Campbell Scientific sensor also. But interestingly, I just would like to add that along with the soil temperature and soil moisture at different depths, we also used leaf wetness and leaf temperature measurements also, in addition to the soil moisture and soil temperature. And this is purely for the agriculture purposes. Our intention, our purpose was to support the agriculture products and the model. So we have attempted in that direction. So well, observation up to let us say attempted the three main depths we have been using. One is at 10 centimeters, 50 centimeters, and 100 centimeters in our recent models of AWS. So these are the three depths which are we found essentially required for the agriculture purpose. They are at 10 centimeters depth, 30 centimeters depth, and 50 centimeters depth, 100 centimeters depth. That is the soil moisture requirement at these levels. Uh, Having said that, IMD also has generated, I mean, very recently, soil moisture soil moisture information using graded rainfall and soil properties using soil water balance technique. And this is a pan along with the pan India, and this was started in 2017. So we have resolution of 0.25 by 0.25 degrees. I mean, almost 25 kilometers. It's a larger network. There are some other things are available from Japan meteorological section. Probably we have 9 meter by 9 kilometer by 9 kilometer resolution. Um, uh, and we have a network of almost 6,955 rain gauges. That data is being utilized. Then soil water balance from simple soil and climate data. That method was by Thornthwaite and Mather in 1955. What they have derived from that, we have used the soil water volume. Well, recently I came to know that Google is also trying to establishing a soil moisture network in India. This is just I heard about it. There are practical problems in installation of this type of sensors. See, there are in particularly varied type of soils we have. After every season, there is a plowing system is there. So you take out all the grains and all the vegetables from there, and you start afresh. So the sensors deployment there is a difficulty. Now, I'm just telling the difficulties in installation of the sensors, especially in India, the field problems. The first is the deployment, where to deploy them, for what application. I mean, that is the necessary point what I feel I should address here. And if that is required for agriculture purpose, this is a bit difficulty in developing that particular sensors in such a way that sensor uses such a technique that there are n number of problems it has to face. Uh, the soil which are first of all the soil which has to be choose that is floody type, where the floods are frequent, or we can have a sprinkler that can be used in agriculture. We have a river basin where this can be used. We have semi arid soils. We have uh, totally dry soils where some soils are added into that, and the crops are taken. So they're put externally on a kilometers of area, and there the sensors have been placed. So apart from that, the animals, they cut the cables. I mean, if the sensors is having the cables are getting cut very often. The sensors with the batteries, if they are being used, the batteries are getting drained out very fast, and it should have the solar panel, solar backup systems for this type of sensors. So these are all varied experiences I just wanted to share you before we actually try to deploy the soil moisture and soil temperature sensors, especially for the agriculture purpose. If it is for some other purposes, well, we can take it in that some other methods that can be used. My personal opinion I just want to give is, let us use this satellite data and the ground truth by the sensors. Combined efforts have to be made. I mean, just not stand alone the sensor network, soil moisture sensor network, but let us have the satellite data imposed on that, and from that we can select the particular places, and from there we can go to the real ground and verify this data reference to this. Now this has got n number of applications. Now the particularly if it is useful for the farmers, how to make them useful. This is I'm talking about agriculture perspective, agriculture point of view only. This is what for the network is so far being used in IMD as well as in other resources. So state government of Maharashtra also is planning to install such sensors in and around Aurangabad or Jalna districts of Maharashtra. So these are all the various challenges I just expressed when I faced it during the installation, and definitely this can be looked as a combined efforts to overcome to these problems. So this is from my side. Thank you, Dr. Bhushan.
Thank you. Thank you so much, Dr. Mali. You have shared your extensive, all experience and valuable insight actually into deployment of the sensor. And I think, so far what Dr. Franz and Dr. Mali said converge. This data has to be data assimilation, or this how this satellite data and the sensor network that has to be, worked out. That is to be worked out. So, to move next panelist, I would like to invite now Dr. Dev Niyogi. He has joined. Dr. Dev Niyogi from University of Texas at Austin. We have been very closely working with him. Dr. Dev Niyogi has a specialization in land surface processes and carried out extensive diagnostics analysis using observations and modeling experiment. Dr. Dev, we are keen to know your view on the importance of soil moisture monitoring in climate and weather systems. Dr. Dev, please.
Thank you, and good afternoon, good morning to everyone. Always a pleasure to meet my friends and to see this amazing, inspiring people that I just look forward to interacting with. I have a few slides if I can share quickly.
Yeah, please.
So while I'm trying to do that, let me
Yeah.
just say that one of the manner in which I've been involved, maybe I'm not sure if I'm able to share this, but let me try again.
You have to share your entire screen actually. Then it will
Okay,
be possible. Yeah.
screen share,
Yeah. And
and
then
then entire screen. Okay, got it.
yeah.
Are you able to see now? Are you able to see
Yes.
this?
Yeah. 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 Yeah.
Okay, excellent. Thank you. So I'll just say that the role of soil moisture and uh, its value within the Indian context, I had been deeply appreciative of that. I started off with my first field experiment in the Indian Institute of Sciences. This was part of a vegetation energy balance study in 1990s. This was around the time that I was with Professor Narsimha, who I was very sorry to hear pass away. This was part of the when they had created the monsoon trough boundary layer experiment, the Montplex. Around that time, I was doing a field experiment in the University of Agriculture Sciences and ISC. We started with the soil moisture measurements, gravimetric and other set of sensors that went through. And then this was, of course, the very landmark experiment from the Indian perspective, surface process experiment at Anand, Dr. Wernicker and others who were involved. I was very fortunate to be involved with the Anand site at that point. Go and see that. Subsequent to that, as a deep impact it had on me, it continued working and we created a network in North Carolina called the North Carolina Environmental and Climate Observation Network, which had till date from 2000 soil temperature data at multiple depths that is being shared across freely on the websites, available every 15 minutes. And early data are generally widely used. Uh, a part of my continued work was my master's and PhD, which was soil moisture feedbacks on land atmosphere interactions and soil moisture CO2 feedbacks in the land surface models, translating from what we have heard about measurements to soil moisture. Over the years, in the last 20 years or so, my work has used soil moisture for boundary layer studies, air pollution studies, numerical weather prediction impacts, monsoon depressions, and how monsoon depressions sustain longer if we have wetter soil conditions, and then in more recent times on tropical cyclones in what we call the brown ocean effect, meaning that if we know the soil moisture state as a system is making landfall, we can understand whether it is going to stay longer inland or not. As a value to this, as part of the National Monsoon Mission, I was involved with the development of the soil moisture land surface fields, and I'll share some of that information. And ongoing currently, we have at IIT Hyderabad a soil moisture flux footprint experiment going on, where the problem is that you have heterogeneous fields, and in that, what is the network associated with that is a challenge, and I'll discuss very briefly on that. Right now, I'm part of the NASA Cygnus, which is the Cyclone Global Navigation System science team, and one of the product from the Cygnus soil moisture satellite is soil moisture, soil temperature, which has resonance with some of the other things that were talked about. Very quickly, this is the WebEx paper that came on, and we had in early 90s. This was as part of the ISC, as I mentioned. We had one season, but this was a really useful data from that side to get into that process. These are the IITM IMD 30 plus year, 4 kilometers sub-daily gridded soil moisture, soil temperature data that are available as part of the National Monsoon Mission. We have the CD, both available at IMD and IITM, which has this 4 kilometer sub-daily data across India. Subsequently, we have it also in the US and so forth. Here's an example of what I meant about the impact of soil moisture on the post landfall, that when you have more wet conditions, the system sustains much longer. And this is something we had seen with regards to what we see for Indian monsoon conditions, where the monsoon depressions, they have a much longer track inland if we have wetter soil conditions. So the understanding of the antecedent, which is 7 to 14 days prior to making landfall, uh, antecedent soil moisture conditions had a profound impact in the manner in which the system could either sustain closer to the land, and if the soils were wet, then the system could go about 50% more inland. And there are a number of these studies which are published in WRR and other journals related to that. So, what are some of the challenges that we see? Prior experts have already identified that. But first and foremost, that this is not a simple measurement. This is a difficult measurement by its nature. It's labor intensive, it is undervalued, and more often than not, it is underutilized, and people don't necessarily have the appreciation how important this is. The second challenge is that this is the footprint of the measurement. What are we measuring? Are we measuring soil moisture at that point, or is that soil moisture representative of a larger system? The assessment of the footprint, that is really quite important, that needs to be shared. The third aspect related to the footprint is the scaling aspect, that how are people to use this will depend on not just the measurement at that point, but really in the context of whether it is going to be used for a numerical weather prediction forecast verification. Is it going to be part of a crop system, or is it going to be for climate studies? The scaling requires necessary steps which are from the field measurements to product development, and that translation is really, I think sometimes things get won or lost in terms of what happens to the soil moisture data. The maintenance, which Dr. Mali also mentioned, is a pretty important issue, especially in the monsoon setup, where we have an extreme wet and extreme dry conditions, in which the sensor may or may not be calibrated that frequently. I mean, how do you measure things when they're completely dry to completely saturated? And so it requires a different kind of assessments and analysis. And the most important challenge, as I mentioned, is the value proposition. People sort of know it is important, but people are still not using it to the value of saying, aha, this is my number one priority that needs to go. So what are the opportunities? This is my last slide. I think the first one is data access. If we really want this to popularize, we need more people to use it. It is a simple user-driven proposition that the more people use something, the more popular it is going to be. The more popular it is going to be, the more support it is going to have for its development. And that starts with data access. I was trying to look at the Cosmos data. I was not able to access it. And I'm sure it is there, but you have to make it easily available. More collaborations internationally, just because this is such a widely appreciated field, but people are dispersed and you need to create that network. Second is use and misuse. Very often people just use soil moisture and they say, okay, that data is good or the data is not good, without recognizing how the data ought to be used. And the onus is on the people who develop that data and provide that information, how that ought to be used. So the guidance has to come from them. It has critical utility for climate studies. As I said, as a part of the Cygnus Science team, I can help with some of the verification and other aspects that go in terms of the soil moisture. There are new sensor missions coming up for soil moisture, especially as Dr. Krishnan mentioned of Dr. Manabe's work. And for those who don't know, Dr. Krishnan was one of Dr. Manabe's student. So he is very much aware of the value of this kind of work, even before all of us probably started working on this. It is not just the soil moisture that we need to probably share, but it is the soil moisture availability. And what does that mean? Very often, the sensor provides soil moisture, and that soil moisture is relative to the saturation or the field capacity of that particular field. When you're comparing it against a model, the model soil texture and the field soil texture may or may not be same, but you can get the relative soil moisture and use that as a calibration, and so use that in the context. And again, I highlight the point of scalability, that when you're developing this measurements or protocols, how they are going to be used would really be important. In the context of the new sensors, at the end, we really need them to be simple. but their robustness really needs to be tested out. And I've seen enough example where people come up with a new sensor, they show some measurements which are great for a month, but many of these things require a character that should last for multiple years, and that would be something I would recommend that we think about. Simple, robust, but rather than giving an output only from the sensor, the focus ought to be from development of products and graded output, and then that graded output is what is being used by the larger community. With that, I'll stop my sharing, and I hope you were able to hear me and it was helpful.
Thank you.
Thank you.
Thank you so much, Dr. Dev. You're elaborating on the use of soil moisture data in climate and weather. A lot of issues what you told, actually this is very close to our heart, and challenges what particularly you told. I mean scaling, either it is scaling, it is maintenance or deployment, or robustness, various issues, and then availability, data availability. Of course, I mean the very beginning what Dr. France also said, this how this data can be directly used for NWP. That is the main issue, and then Dr. Mali also highlighted the same issue. Definitely, we need much more guidance on this, and we need to really brainstorm more how to go about this. The power supply, every small issues. What Dr. Mali also said, what you also said. These are really, I mean, we have to really think about footprint also. What data we are collecting, how we are calibrating, how we are validating. These things are really important. So, I mean, moving ahead, we should have more time actually to discuss each and every point very carefully. But I mean, due to pause at this time, we'll just be brief in this first initiative. Maybe I mean later we may have more opportunities to discuss in each and every point in detail actually. So now I invite Dr. Venugopal Premnath, Head NCL Innovation and Director Venture Center. Sir, as I understand, I'm sorry, I mean, I could not put this in our this brochure correctly, but he's the head and NCL and Innovation and Director Venture Center. Sir, if I understand, you have been involved in setting up various startups and promoting them. It would be really beneficial for us to know your professional view on these occasions. Dr. Venu.
Thank you very much. Can you hear me?
Yeah, absolutely, sir.
Okay. Yeah. Good evening, everybody, and good morning to people joining in from the US. First of all, disclaimer: I'm not a soil or a moisture sensor expert. My focus is more on technology commercialization, so I'll share my perspective from that angle. Just a little bit of background. The NCL Innovation Park, which is right opposite to the IITM campus, is home to the Venture Center, which is one of India's leading inventive enterprises incubators. And one of the areas which we focus on is agriculture. Of course, we do have other areas of interest, which including health, energy, environment, and so on and so forth. But there are a lot of startups in this space which we do engage with from time to time. In particular, let me talk a little bit about soil testing. But before that, let me talk about the fact that when you talk about, I'm primarily talking here about startups, and let me tell you what I mean by that, first of all. Startups are a kind of business which basically is looking at a future opportunity and is trying to solve a problem. And in our case, because we look at inventive startups, we are typically looking at technology innovations. But occasionally, and especially when you're encountering a problem like Indian farms, you need to also think about business process innovations. You cannot do them separately. It's quite a challenge to introduce things in Indian farms. So many of our startups are working under that environment, and they need to find ways to solve the problem that farmers face and also do it in a commercially viable manner. So the business model is equally important. So in this context, when you look at soil testing broadly and moisture testing in more specifically, the startup would like to have, I mean, any kind of such companies would like to ensure that they are not they are as independent in their ability to deliver the solutions, in the sense that they should not be, they should be, the entire service delivery mechanism has to be very reliable. The data access should not be a problem. The cost at which it is available has to be within what is viable for within the business models that the farmers are capable of sustaining. And typically we see that in the Indian farms, the data quality is not reliable right now. It is the granularity of the data is not sufficient. Please remember that Indian farms are very small farms, and you need to have a lot more granularity, and having one sensor network which covers a very large area may or may not be adequate. The farmer has to take a decision at the scale of a few acres that he might own of land, and his decision is independent of his neighbor's decision, and therefore that granularity becomes very important. Plus, we are also seeing a lot of issues relating to sampling of soil, the processing of it, and associated data quality, data that emerges out of it. There's also a lot of issues relating to logistics of getting it tested. There are issues relating to costs, and as India is a very cost-sensitive market, but at the same time, it has to be viable. And I'll come back to the business model in a little while. And of course, the maintenance issue is also very important, as I think one of the participants spoke about just now. There are no local capabilities for upkeep, and therefore, it is important to keep such considerations in mind while building business models. So typical business models will not, and one more thing to keep in mind is that the startups will not be able to raise a lot of money for asset-heavy business models. So if you create a sensor platform or a network which is extremely expensive or capex intensive, the chances of them raising money around it is fairly low, and therefore things start to fall apart. So you want self-contained operations. You don't want a very asset-heavy model. So how would you make it work is a question. So many startups would probably be looking at running the whole network themselves and ensuring that the farmers are paying for the results that they get out of the insights that come from the data and the data analysis that comes out of it. So that is what we are seeing. We do have startups in the sensor space, but I think the final test of all this is going to be where farmers are paying for the gains that they're making on the farms thanks to the data and the insights that come out of it. So when we look at such things, we have to look at the whole gamut of steps and not merely the sensor. Sensing is one part of the story. The next step is the data collection and processing. And there are companies which are looking at both the edge and the cloud computing models. Cloud may not work out if, say, the signal connectivity is very poor in many rural areas. That will be the situation. So how do you work around that, and what is the solution for that? Data compilation, processing, and analysis and models. Of course, there's a lot of work which is happening using AI ML kind of models. The training data is a big challenge still. I can see that. And of course, the recommendation engines for farmers and the interface for the farmers to make use of those recommendations, and finally also the actions that they can take based on those recommendations. So we have also startups looking at some of this. So I'll conclude with a few just examples. So we do have companies which are doing sensing, trying to do sensing the hard way, with mobile or labs located locally. The ICAR has come up with some kits for different types of soil testing, and those are things which are a little cumbersome, but nonetheless there are creative, enterprising folks trying to do it at the farm level. There's also hybrid sensors, hybrid mechanisms where people are trying to use a combination of mechanization along to reduce certain variabilities, increase the granularity of data collection, and then use a lab at the back end. There's also people who have sensors being developed to look at moisture levels. I don't necessarily understand the details of it, but at least we have a few companies which are using it to look at moisture at different heights, different levels, to be able to get out enough data for irrigation insights, local drip irrigation insights for farmers. So examples include companies like Sensitout, Proximal Soil Sense, both Pune, Bombay companies. In Nasik, we have a company which is looking at grape farms called Drew Farm. And then there are, of course, guys who are trying to do it the non-contact way. There is a company which is looking at techniques based on Raman spectroscopy for some of this sensing. There's another which is doing soil analysis using certain data which they can capture with drones. There's a company which goes all the way to giving advice to farmers with local data. They, of course, right now use a lot of manual data as well, because the situation is not there yet, but manually collected data, but the full service model of coming up with advice for farmers, crop specific, farm specific advice based on data collection done. So it's laborious work, but nonetheless, that's what is working, and they have raised money. And then, of course, there are companies looking at satellite data as well. And in that space, there are some very large companies in India also who are trying to do this. I remember seeing something with Rallies, which is a Tata's company, also trying to do some of this as well. So that's broadly an overview of the startup and technology commercialization world that we are seeing. I do realize it might be different from the kind of moisture testing that you might be talking about, but nonetheless, I hope these insights are helpful. Thank you.
Sure, Dr. Venugopal Premnathji. This is really very insightful, your view, the professional view, and definitely I'm sure, I mean, this will be very helpful to involve and to integrate with these stakeholders. How to involve the stakeholders, unless until we have this commercial, and this if we really want to expand this network. So all these practical aspects, what you have narrated, actually, you have vast practical aspect, and very true that startups, what you have really contributed for the startups, and how it can go to a particular farm at farm level. What you have given the insight is a particular farm level. Definitely, I mean, we are interested in data. Definitely, we have the interest, scientific interest, but the data has to come from farm. And for that, actually, these practical aspects, whatever you have really narrated, each and every aspect is very important. We will definitely note it, and then in subsequent discussions and subsequent this panel discussions and meetings, we will definitely look into those very carefully, and we will be in touch with you. So moving next, actually, now I would like to invite Professor Dr. N.B. Chopde. He is Director Electronics and Telecommunication Department, Pimpri Chinchwad College of Engineering, Pune. Sir, you are involved with us through your students internship program at CCCR IITM. You are kind enough, I mean, you have visited and you have really initiated a good, and you have set up this research and development units at your college, getting as a autonomous status for your college. So it is really prestigious to work with you and to interact with you. So we would like to have your experience, I mean, techno-scientific experience in an interaction with CCCR IITM research. Actually, I want to say that, I mean, it is very rare, very difficult to get dedicated faculty and the students to work on these petty, I mean, this is a very critical issue, but for engineers and for professional aspects, it may not be that, but these students have been working very, very sincerely, nicely. I mean, they have developed these sensors, and now the testing and various works are going on. So Dr. Chopde, I would like to hear from you.
Thank you, sir. Listening to the earlier eminent speakers, it is really a very what I can say, a very new experience for me. Being working in the autonomous academic institute and specifically working on the interdisciplinary verticals, because this soil moist sensor interfacing and designing the controllers and working on the data, that is our cup of tea, technical side. But listening to the potential and the eminent speakers, specifically Dr. Niyogi and our earlier discussion also, Nobel laureate and his Shishya. So really it is a great experience. Now I have 2 points to mention here. Number 1, being academic institute and autonomous institute, PCCO is always focusing for the interdisciplinary research. When I use the word research, it includes the system design and solutions to the multidisciplinary problems. And we have identified rather few thrust areas, and agroelectronics is one of the thrust area. And we are promoting this feature, this working among the faculty as well as students. And one of the group where the sir have highlighted CCT IITM, so where they are working as an entrance and they are working specifically on the soil moisture sensors. They are interfacing and they use the very simple controller Raspberry Pi for making the interfacing and controlling the data. But sir, I am very proudly say that we have very good research facility and many faculty, say in the tune of 70 faculty, they are pursuing the PhD, and we are promoting the interdisciplinary thing. Again, I am highlighting. And in our laboratory, such facilities are existing. This is one problem statement we have identified and we are working, but there are many others where probably we can say work together, and whatever the presentations Dr. Venugopal sir and the eminent speaker again Dr. Franz, and they have highlighted. So definitely some problems can be taken ahead with the help of the faculty and the students together. So that is my first point. Some in the discussion, the point were mentioned about the satellite data and wireless sensor networks and extending the team, say getting the data from the farmers, and practical difficulties also were mentioned. So on so few projects, our information technology department, students and faculty together, they are working along with the farmers. And there is one platform, it is called as the TIFAN, TIFAN, Technology Forecasting, Technology Innovation Forecasting for specifically for the farmers. And our team have developed a onion and the potato harvester. It is indigenously designed by our faculty and student team, and it will be deployed in the farmers, nearby farmers in Chakan and I hope some Rajgurunagar area where they are actually using it. So, and we got the special award for that design and for the model itself. So just for information, I have it may be some different area, but again it is highlighting the agroelectronics and agromechanical, whatever the name can be given. So the students are working. And second thing is that we have AI and ML experts in our institute. So many forecasting models they are working upon. And if you can share, we have earlier discussion with Dr. Milin sir, that if we could get the satellite data, so probably some of our prediction model may be validated with the help of this data, and it might be useful for the farmers also. So in that sense, definitely we can handhold your team, your scientific team, and certain solutions to the problems can be given. So these are the 2 points from my side, sir. Thank you.
Thank you. Thank you, Dr. Professor Chopde. This is really very insightful, because the thing is, our attempt is, as Dr. Krishnan has been always emphasizing on outreach also. We do a lot of R&D, but it has to reach to the society, and particularly to academia, and academic faculties should be on board. So this is an attempt actually to go with the academic, and these simple senses, whatever the contribution is coming, first of all, to generate the awareness, to generate the interest, to make the students interested in this field, and to work on the ground, actually to come and work in the ground. Mitti ke saath judna, what we say is actually to be associated with the clay. That is very important, because everybody want to do rocket science, but it starts from this only. So I think, this is very important actually to be with you, and to integrate it. This way definitely this will percolate. The expertise, what we have, the expertise, really world class expertise are there in this August gathering, and this will definitely, the whole knowledge, their expertise will percolate to the students. That is what is actually main aim is this outreach not only of CCC or IITM, but this IIFS also, India International Festival, this science festival. So this is the main objective, and I think we are on the right track. So now finally, for the first round, I would like to welcome Mr. Shantanu Pendarkar from Akshay Measurement, Pune. He is having vast professional and commercial experience in dealing with hydrometeorological observational instruments, sensors, and I'm very proud to say that some of the difficulties we faced in this Cosmos observation system, data logger particularly, they were able to solve beyond the professional, our relation. They have gone beyond it, and they have solved these difficulties. So we are keen to hear your professional view promoting the soil moisture observational system in India, sir. Please, sir, Pendarkar, sir.
Yes, thank you very much, sir, Dr. Mujumdar, sir. Good evening, everybody. All the eminent delegates, they have expressed their wonderful experiences, and they have shared vast knowledge before us. I welcome everybody at this gathering, Augustus gathering, as you said. We are Akshay Measurements Private Limited. We are formed in 2003 as a total instrumentation company, and we provide innovative and value-added solutions in the field of test and measurements and automatic weather station, sensors and instrumentation. This is our main thrust area. Data logging and data acquisition is our main thrust area, and we have got experience of almost 60 man years in this particular domain. And we have very much thankful that you all give us the opportunity to present us before this gathering, and we are very much thankful for the hosting this wonderful seminar on soil moisture monitoring with this Cosmos sensors. And our team have got opportunity to work with the team of Dr. Milind Mujumdar sir and Dr. Mangesh Goswami for his prestigious project of cosmic ray monitoring system, which is installed at IITM, and this is a really wonderful experience our team has got, comprises of Rakesh and Girish. We have integrated our data logger with this cosmic sensor, and presently data is being measured and logged in our data logger. I'm very much delighted that we got this prestigious opportunity of serving the total facility generated by Dr. Milind Mujumdar and team, led by Dr. Krishnan sir, and we had done this integration by decoding their addresses and protocol with the special capabilities of SDI 12 protocol about 2 years or 3 years back. And I'm very happy that this particular facility is working very fine since last 3.5 years, maybe, Dr. Muzumdar sir. And we can measure volumetric water content and neutron counts very effectively, and data is also coming very nicely. Then about the soil moisture monitoring challenges and opportunities. Basically, I would conclude following points as a limitation of use of normal present soil moisture sensors. Normally, our pressure or this particularly soil moisture sensors, they have got a conductive type, and if the rather this field is very, if particularly I'm talking about this agricultural domain, when the agriculture farm is large scale, then wiring and connection is a problem. So this particularly telemetry type of this system of Cosmos sensor is very great. Then availability of this technology should be, these are the challenges I am first of all discussing. Availability of this technology should be at lower cost per hectare, and increase in soil depth monitoring scope up to 1 meter should be there, because in particularly our India, ज्याला आपण म्हणतो की दुबार पेरणीचं जे संकट असतं ते शेतकऱ्यांसाठी खूप महत्त्वाचं असतं. मीन्स इन इंग्लिश आय विल टेल यू दिस सोइंग ऑफ द particularly season is requires total wetness of this soil up to the order of 60 millimeters, and this particularly at our this particular thing is about 60. So but what we prefer, or rather this technology should be made available up to 1 meter. That will be great. Then analysis of the data. Commonly these now the expertise is like these particularly what we are gathering today, those are experts, but the people like us which are new in this particular area, they should get more training and awareness so that we can also propagate this in a greater level, and its commercial uses as well as its applications in agriculture and other hydrology and other projects. This smaller area should be available for micro irrigation needs to be focused. Means what I mean to say in this point is area of this particular in India, as somebody mentioned, the farms in India are very small. So to the order of say few acres, 5 acres, 10 acres, like that. So this particular reading or this data should be available on the micro irrigation, so that the projects, huge project means small projects of drip irrigation can be implemented with using this data. Presently the agriculture automation projects are on large scale, but this particularly if the technology is available for small areas and the depth can be increased, then it can have a more this particularly impact on the agriculture productivity, and the farmers will be benefited. Next. So these are the opportunities, larger benefits of agriculture sector by effective crop and water management. This is the one opportunity, means the more agriculture sector will be benefited by effective crop and water management. Means this especially the crops like grapes, then flowers and all that. These particular this type of crops require good water moistures, and if they maintain it good, they have got a good data, then this particular sector of the cash crop manufacturers, they get benefited. If the low cost solution of the specific area is defined, it will be more advantageous to small and micro and medium irrigation projects, as I have explained already in the last slide. If the government irrigation department gets such data in the region and soil moisture contents, they will be able to manage the control of water in a better way. In such cases, they can get direct water. This particular excess water can be given to scarcity zones. So in irrigation department, it's a better tool to get more control over the water management. Many times excess water is being used by the farming community. When the water is available at the particular locations, आपण ज्याला बागायत म्हणतो, तिथे जास्त पाणी जेव्हा असतं उपलब्ध, त्यावेळेला ते शेतकऱ्यांची अशी एक भावना असते की भरपूर पाणी वापरायचं. आपण जर इफ वी create a awareness that when the water is available, it is on the availability basis. Means suppose the water moisture is, or other soil moisture is better, then the water should be should be made available to them, so that scarcity zone can be getting more water. For the irrigation, on the basis of this data, they can control the use of water more effectively. These are the strong points and opportunities what we feel about the effective use of water moisture, this particularly technology which is available. So thank you for patient listening, and please continue, sir.
Thank you. Thank you so much, Dr. Shantanu Pandarkar ji. And it's really, I mean, nice to work with you and to extend really our all these instruments and observation systems. What you said is absolutely correct. This SDI system, that is the main thing is, and then this is what has been Mangesh also has been emphasizing, and particularly the inductive and conductive sensors. What is this? How we should go about it, and particularly up to the 1 meter depth, the emphasis on 1 meter depth. So all the panelists, they have really given a good insightful. So now we can have few questions, and then after this we can have a quick round of the comments from each of the panelists. So there are some questions on YouTube. This first thing is for which exam? Given the broad Indian region and heterogeneity, what could be optimum number of Cosmos stations or even point observations of soil moisture? So this I mean, this could be the question to Dr. France. He may what could be the optimum number of Cosmos stations?
Yeah, so we looked at this in the United States, that particular question for the original Cosmos project, and the original goal was I think 3,500 stations across the U.S. That was scaled back to a couple hundred sites. So from my experience, it seems that the Cosmos sensor is pretty representative of soil moisture over the several kilometers, maybe even to a few tens of kilometers. So I think in terms of integrating it with the numerical weather prediction, a station every several tens to 50 kilometers would be ideal. Obviously, that's very expensive. So I think another strategy would be to pick different climatological regions, land use, and put them in there and distribute the sensors that way. So I think you can also do a reverse analysis of where you look at some of the sensitive regions using the numerical weather models to identify critical areas with the land surface coupling, and you use that to guide your sampling strategy. So I think it's an open-ended question. Obviously depends on resources and what question you're really trying to get after of how you would answer that. So yeah, open to other comments as well.
Thank you so much. We'll go to the next.
I'll just comment quickly to that.
Please.
That was actually a very great answer by Trent. The bottom line here is, what is the use you're going to have. If your intent is to use it as a verification site for models, then you need few representative sensors with highly robust data, almost along the lines of what CRN has done. If your intent is to develop a scalable product blended with satellite data sets, then you need to have it along the lines where you might have the footprints for SysMap or uh, Cygnus or any other data set, and put it in that transect and try to develop a calibration from that. If your intent is, as I said, developing some guidance, like what Dr. Pendarkar was saying, then you could have it in irrigated, non-irrigated, agriculture, non-irrigated, those kind of setup, forest, non-forest, urban, non-forest, or different land use. So I would say, before we answer this question, let's be clear on what we are trying to do, and then come up with the framework going forward.
Yes, that is also important, and this is a really a great challenge actually. In fact, it is a challenge. How to optimize this effort. I mean, scaling, soil moisture scaling. How to optimize this. This is ever going to remain challenge. But yes, how to face it. How to face it. So what points you have? I mean, various consideration we should have before we optimize this. Yes, definitely we need to have what for we are doing this, how we are, what is our objective. Yes, that's very true. But I mean, mind it, this we have two aspects here. One thing is the science, particularly science, NWP, data assimilation, all these things. And second one is the agriculture applications, irrigation or hydrological applications. So these two things, how to find a good mean between these two requirements. That is also an important thing, I feel. So will any expert would like to again comment on this question, or should we move to next?
I have one small question. I mean, it's not a question, but then it's 10 to 15 kilometer area, one Cosmos sensor we can have. That is what is proposed here. So, but 10 to kilometer, in my view, it's a little more considering the Indian conditions, Indian soil conditions. Various types of crops, they are generated with a smaller farming farmers and by smaller people in the remote area especially. So I think we can still reduce it to as it was said in 4 kilometers by 4 kilometers, or maybe 5 kilometers area, and let us plan it out for a particular district or particular taluk level as an experiment on the first trial basis, and then we can expand on it. This is my views.
Absolutely. That is how we have started India, this Cosmos India network actually. So few stations, what you see, these probes, and exactly as Professor Dev Niyogi also said, this is what we are trying to validate it for various products. As Franz said, I mean, this across US also, how this network has been developed. And how this data is being used actually for data assimilation. So this is how we have started. We started with, I think, Cosmos India network with the collaboration with Indo-UK all scientific forums. So we had initiated this. So definitely we need to really think, and the main thing is the funding. Again, we will come to that aspect. I mean, funding is again financial support or funding is an important issue. I think I will go to next question if it is okay for panelists. Is it okay? I'll go to next question.
Yeah.
Thank you. So with the fast, there is a question with the faster land warming than the ocean, are the soil moisture feedbacks becoming more important in future evolution of climate, particularly temperature extremes? So this is an open question. I mean, this is an open question. So is it this extreme event for this extreme temperature as well as the rainfall extremes? Yes. So
yes. Can I respond to that?
Please.
Yeah, yeah. I think it is very clear. Right now, we are getting continuous rain in Tamil Nadu, in Chennai, and many places. It's almost, of course, there are low pressure systems forming in the Bay of Bengal, and we have been seeing this for last almost 10 days, continuous rains, and this is expected to continue. And as Professor Dev Niyogi rightly mentioned, how the land surface conditions, soil moisture conditions are there's a preconditioning, and that can have a significant impact on the extreme rainfall. And so can we test it out? Because in 2015 also there was this very heavy rainfall in Chennai in December 2015, and that was a different problem. And because the dam was released, one of the dams, suddenly the water was released, and also there are several land changes that have taken place. Many lakes have been completely destroyed, and construction has taken place. So land use, land cover changes have also occurred. But this time the problem is different. I think the weather systems are getting really, I mean, one after one, I think the low pressure systems are intensifying, and rainfall is continuous, although the intensity is also quite high, 200 millimeters in a day, and recently 2 days back. And this season already we have exceeded, just November is, usually it's October, November, December. Already we have exceeded 1000 millimeters of rain in Chennai, I think, something like that. So it's so the rains are very, very persistent. So I'm just wondering what may be the role of the soil moisture, and this is also having big impact on the agriculture. Agricultural impacts are very profound. Hydrological impacts are profound. So based on all the arguments, and also Dr. Franz was telling that how do we assimilate this data into NWP models? And so probably we have to, if we can build a nice proof of concept for developing this whole idea of, I mean, because on the one hand we have the scientific and technological issues, and there is other issue of sensor development. And then there is a issue of going to the stakeholders like farmers, and what are the commercial aspects linked to that. So I think we have to build, so it has to be viewed from different angles. But I think if we can develop a good proof of concept that with this changing climate, these type of extreme rainfall events are happening, and what is the role of soil moisture in producing these extreme events, and what will be its impact on the precipitation, and also on the flood and the hydrological and agricultural impacts. If we can build a nice proof of concept and start with whatever available products we are having, then how to improve that? I think we have to do it step by step. And I also like the presentation by Mr. Shantanu. Very nicely he has conducted. He has highlighted all the practical, both opportunities and challenges. And so if we want to really benefit the government, or even at the micro level irrigation practices, we have to make our science strong. That will be very, very important, and develop good products.
Yeah.
And, so that is and already the 4-kilometer product which Dr. Dev had mentioned, how effectively are we using it? Can we do some more groundwork on that? So these are my loose thoughts, not well organized. Yeah.
Thank you, sir. I will go to next question.
Yeah, Dr. Muzumdar, I'll quickly add on to that.
Yes,
because the Chennai and another issue came up, the issue is always the hammer and a chisel. The large-scale system gets formed because of the synoptic setting, the climate setting. But why do we get an effect or an impact at a particular location? That is always a challenge. That why it's only Chennai? Why not Bhubaneswar? Why not Kerala? Why did it go there? The reason for that is certain preconditions that get formed, and because the system is on the land, and what creates that precondition? So there are three factors. One is land use change, which is a more long term. The second like urbanization and so forth. The second is a more transient one, which is dictated by vegetation and soil moisture. And third is, of course, the interaction of the mesoscale and synoptic scale interaction, because there could be a front coming in and a large scale coming in, and those three coming together. So we cannot control the number one because it has happened. Urbanization has occurred. Soil moisture, we know we can observe it, but we don't have the capacity built in right now. And so we need to build that. And the third, of course, is a well-tracked system in terms of the atmospherics, but it is that variable soil moisture opportunity we have is that conversion zone on the soil happening over that region that we need to have a better capacity to monitor. And if we do that, we might have a better predictability as to where the impact may be directed. So that was a great point by Dr. Krishnan, and we need to follow up on that.
Thank you, Professor Dev Niyogi. And in line with this, I mean, next question is, why do we need to have this what frequency we should have this soil moisture observations? So this is again open question. I mean, the question is it the hourly, sub-daily, or daily, or weekly? What time scale we should have this soil moisture observation? Obviously, I mean, I will go for hourly soil moisture observations. I mean, we have done the analysis, but I leave it to panelists. Please take it over. Maybe we can start from France. Why we need this high frequency soil moisture data?
Yep. Again, I think it gets back into the how it's used in the numerical models and what are the processes you're trying to represent. So certainly the atmospheric processes, hourly or even sub-hourly, are going to be very important if you think about convective storms and those development. I've done quite a bit of work in agriculture in the U.S. recently, and there I think daily or every couple of days is certainly sufficient for irrigation management and water management. So I think you can certainly relax that hourly or sub-hourly data if you're going to agriculture. So again, it has to do with what is the question and the process you're trying to actually quantify or make an impact or decision on is really going to guide that temporal frequency. So,
thank you, Professor Dev. You have any?
My question.
Yeah, please go ahead.
Yeah, my question to Dr. Francis: what should be the target prices if we have a more number of orders, and we look at the mesh of such sensors?
May I interrupt, sir? Sir, this question we will take just next to this. Just right, please hold on. We'll just continue with this. Why we need high frequency soil moisture data?
Okay.
What frequency we should have? I mean, I will come to you for this. I mean, applications also. Do we need really high frequency soil moisture data? That is what is. Yeah, Professor Dev.
Yes. No, of course, the bottom answer is yes, we need that. And if you have more high frequency measurements, the better it is going to be for a wide range of things, because you can average it out to get the lower frequency. If you have a low frequency measurements, it's very difficult to get the high frequency output. So by just that logic, it is necessary. However, the question again boils down to the same aspect that we had for the spatial aspect, that what is the application? And for many aspects, I would say you need few sites which are really high frequency, high caliber, interspersed with a combination of a low cost, low fidelity, even to the context of whether it is wet or dry, is it saturated, not saturated, those kind of qualitative aspects would be fair enough for some decisions. But it boils down to, I think the question Dr. Pendarkar was getting to, the cost aspect. You'll have to build it into this kind of analysis going forward.
Thank you. Dr. Mali. Quickly, you can have your view on this. What frequency? Because during the monsoon, Dr. Mali had already brought out this. During the monsoon, it is very crucial and very difficult to, as Professor Dev said, and the saturation condition, it is very difficult to get this data, and there is only way to get it through wireless sensor network. Yeah, maybe Dr. Mali.
Yes. I do agree with the panelist. I mean, I think more number of observation, they will help definitely for the greater averaging and very near real values for that purpose. So I fully agree with high frequency data.
Dr. Venugopal, you have any view? I mean, any professional view to express it here?
No, I think the frequency. See, as the panelists before mentioned, I think we have to go back to the question of how it will be used. Since I've been talking about use in Indian farms, I think the frequency of sampling is essentially a factor of cost versus benefit. So in the case of individual samples, it's easy to calculate how the cost adds up. But when you add a capital expense to it, in the sense that there's a large capital investment involved, it's a little more harder to conceptualize it, right? So
Yes.
I'm thinking of, I mean, I do understand that some of your sensing activities are meant for policy or for government action or for larger scale activities, and that that may require a different frequency of sampling, which is fine, because I think there you're looking at a problem at a much larger scale. I was focusing a little bit more on the smaller problem, and I think we need very frequent sampling. For example, if a farmer is watering his farm and we are looking at what happened in the morning and what is the situation by the next day, you need to have a lot more data points to go with. Right.
Yeah.
So that's my view. Yeah.
Great, sir. Thank you so much, sir. So, any other panelist would like to put the comment on this? If not, then I will go to Dr. Pendarkar, sir. Please, sir. Please go ahead with your question, sir. Sorry for interrupting, sir.
Yeah, no problem. I thought it was end. That's why I intervened. In fact, as I am very keen on particularly the solution. My point of view is always a solution provider to a total community. So my viewpoints are totally different. Maybe you take it as a different, might be, but my intention is not it is not different than yours. Basically, as a solution provider, what our Indian market is very cost conscious, and as a smaller versions of this such a sensors are made available at smaller prices, say to the 20% of the costs that what we are getting today, then that will be a very essentially better to have more data throughout the network of India, and there will be a creation of very good mesh of such a like automatic weather station, as Dr. Mali sir has informed that in IMD there are thousands of such weather stations. So we can create such data of all over India, having more number of stations of this kind. So my intention is only that. And what is the target, and then what is the time frame that we are looking at if we determine to do it? This is my question. Thank you.
Yeah. So this question is aimed to anybody particularly, or
no? It's a general question, but aimed to as a manufacturer or maybe as a provider. It should be to Dr. Franz. But anyone can add, no problem.
Yeah. Dr. Franz, please.
Sure, I can only speak about the sort of price points in the U.S. and some of my experience there. With our producers, certainly, maybe $300 to $400 US is about the price point that farmers are willing to pay in the U.S. And it just has to do with what is the value of water, how much is one centimeter of water in July and August going to affect corn or soybean yield. That's really the calculation that is made, as well as the energy cost of how much it costs to pump that water to apply as irrigation. So the water, we don't pay for water in the U.S. It has other costs and benefits associated with it. So certainly the cosmic ray sensor and other ones are not at a price point that most farmers are going to pay. So I think these lower cost sensors that are, more, 3 or 4 levels of soil moisture, wet, average, or dry, and then how do you make decisions based off of that is really the critical component. So it's really that decision-making process with some information about soil moisture is really what I found. So, but there's certainly value in the higher quality measurements and connecting that with the the calibration of the lower cost sensors or your understanding of what's happening with the land surface feedbacks. So
yes, thank you so much.
Thank you so much.
Yeah, anyone want to again, or should I go for next question? There will be 2 more questions and then we'll conclude. So another the same question. I mean that is the same question was asked. One of the major challenge to make this and scale low cost moisture sensor along with the uninterrupted power supply. What is the opinion of the panelists? So anyway, I mean this is answered. Another thing is it will be interesting to see if increasing or decreasing soil moisture can play a role in the time taken during decay of cyclones after their landfall over the coast of India. So I think, I mean, this question is for Dr. Dev Niyogi. So how does it influence the landfall, cyclone landfall?
Well, the simple framework is that you have to look at the reason why a cyclone sustains itself, and that is availability of moisture. When you have more moisture available in the storm, then the storm has the ability to maintain its energy, which we know that energy is a basis by which the storm moves forward. When the system is offshore, of course, all the moisture is coming from this ocean, and that's how the evaporation drives the storm. When the system makes landfall, then the moisture source is cut off. And when the moisture source is cut off, the storm cyclone starts dying off. That is a fundamental mechanism by which a system is dissipated. But when you have high soil moisture, then there is more ability for that moisture to energize the tropical cyclone even after landfall. And that allows for the system to sustain itself. So the same mechanism that we know are valid over ocean, the principles are same over land, except the source for soil moisture. So the source for moisture is no longer the ocean, but soil moisture. And that is the reason monitoring soil moisture becomes important for the post-landfall time length or the lifespan associated with the cyclone and how long it will continue being a cyclone after making landfall. What we have found is that about 2 weeks to 3 weeks ahead of time, if we monitor the soil state, then if the conditions are wetter than normal, then the system has the potential to go longer inland. If the conditions are drier than normal, then when the system makes landfall, it will be dying off after a short inland track. And if you need more details, there are a couple of papers in Water Resources Research that have actually taken the E-Atlas, India E-Atlas, and we have analyzed all the storms, the monsoon depressions, and done the climatology. And there are a couple of papers, both me and Chandra Kishtawal, who was at the Space Application Center. Chandra was involved with some of that work, and those will be available. And I'll be happy to follow up more on that.
Yeah. I remember, I mean, for the extreme rainfall events also, land use, land cover, you have extensive work with Professor Kishtawal. So the next, question. This is the last question. There are many questions actually, but it will be unending. I will just come to the last question. This soil moisture is critical for land atmosphere coupling with warming weather. The surface fluxes are said to become increasingly important as near surface moisture gradient can change strongly. So I think again this is surface fluxes. So the modulation of the surface fluxes. Yes, Professor Dev. I think this is again question for you. So
no, I think this is a question for Professor Krishnan.
Yeah.
What is the question on land use, land cover?
So the question is, this soil moisture is critical for land atmosphere coupling. With warming, whether the surface fluxes are said to become more increasingly important as near surface moisture gradient can change strongly.
Yeah.
Is it clear, sir?
Yeah, see, soil moisture again depends on the region. For a wet region like right now in peninsular India with the continuous sustained precipitation, there's going to be a lot of moisture for these low pressure. In fact, they're not tropical cyclones, they're low pressure systems, but producing so much rain. It's not just Chennai, entire peninsular India, Karnataka, Andhra Pradesh, Kerala, and even Tamil Nadu. So it is entire peninsular India, the rain has been very, very sustained. So one thing is, so definitely it looks like from what Professor Dev was telling, the preconditioning of the soil moisture seems to have maybe having a very important role. We can probably look at the Cygnus data, which again Dev was mentioning. And he also suggested regarding the number of stations, I think we should synchronize with the satellite track. Where are the tracks and how do we design the locations? Because that will be useful for this calibration and validation of even the satellite data itself. So that will be, so regarding the number of stations, that is one important point. And can we look at some of these latest satellite products to see, and also models, maybe to understand what is the effect of soil moisture on the precipitation, sustained precipitation activity. I think that is an important point. Likewise, in warming climate, maybe the subtropical areas or the dry areas, which are dry, actually soil moisture is low. There may be very extreme events can happen because it is continuously dry. So those areas, if there is, for example, development of a sudden thunderstorm or something, so there it could flare up these heavy precipitation events. So it depends on the scenario. So if it's a wet condition, so the longevity of this rainfall spells and flooding, sustained rainfall can happen. But if it's more of a dry condition, dryness, then it can flare up this sudden thunderstorm type of events. So,
thank you, sir. Thank you so much, sir. So now we will conclude with the concluding remarks from each of the panelists. The important thing here is everybody agrees that we need to have this frequent, high frequency spatio-temporal. I mean, high frequency in the sense spatio-temporal resolution. With the high spatio-temporal resolution, we need to have this soil moisture observation. How to do it? That is a big question, challenge, and of course there are opportunities. But the thing is, how to go about this? I mean, integrating with the academia or the stakeholders or the industry. This is a main question actually. How to make it low cost sensors and definitely, I mean, involving this. Particularly, our interest would be to involve this students, faculties, dedicated faculties and students. I would like to have a quick view. 2 minutes each panelist, and then maybe we can conclude. So we'll start with Professor Franz. Please express your views.
Great. Thank you again for the invitation. So One quick thing I wanted to mention, a lot has come up on agriculture, so I'm going to share a quick presentation. We are working with a gamma ray sensor as well, which is related to the cosmic ray sensor, so another particle you can use. The nice thing about gamma rays is it has a footprint that's about 25-meter radius when you put the sensor the same height as the cosmic ray sensor, so that for smallholder agriculture may be more appropriate for use in India for connecting with farmers and water management there. So I'll share a couple slides on that.
Yeah.
Costs will be similar as well as the cosmic ray, but I think that's potentially a better technology for the lower resolution land units. So yeah, I fully agree that coming up with solutions that are cost effective is really critical. So I think the three things are accuracy, low cost, and then ease of use of the sensor. I think those are the three things that need to go in design of any usable technology, as well as for us is getting that information on a smartphone so that decisions could be made in real time. I think that's the other critical aspect, is that connectivity issue. So yeah, I'll share that presentation, and thank you again, and looking forward to continuing to work with everyone, and nice to finally meet everyone.
Thank you. Okay. So you will be showing the presentation now, or should we go ahead?
No, I think he was planning to send it to us, probably.
Okay, fine. That is fine.
Yeah,
Yeah, can I just request Dr. Franz to also, if he has any studies which have evaluated cost-benefit analysis in farms, which look at different cost parameters and the benefits accruing in farms versus sensors, that would be also interesting information, especially if there's something available even for the US, so that we can extrapolate that a little bit. By the way, just to add to that, recently we were targeting a sensor for $30 in India, which you mentioned $300. So 10x is always what India sometimes asks for. So I think it'll be interesting to see the gamma sensors. We'll see how one could make that work.
Great.
Yeah, I don't have any formal economic analysis, so yeah, I can just kind of my experience. So happy to chat more about that, but I don't have any studies or papers out on that topic. So
Fine. So we'll move ahead. Professor Dev Niyogi.
Thank you again, Professor Milind, Professor Krishnan, and friends. Joy. I mean, there are very few people for whom I'll wake up at 4:30 in the morning, but you're one of those. So always a pleasure. You guys owe me a coffee next time I meet you in Pune, which might actually be in the next 2 weeks, depending on how things go. I'll let you know. But I want to say one thing. I'm really glad this topic is up and front in your vision. This is an extremely important variable. It is a very hard variable, and that is why not many people get into it. But that does not mean we should not do it. If there is, just the way CO2 monitoring has been something which has become the legacy of atmospheric climate change, soil moisture monitoring has the potential of the storage of moisture availability, and there ought to be a long-term reliable data set that can be used from the climate perspective. Let alone the fact that the short-term agricultural hydrometeorological applications make a tremendous economic sense. But I think there is a strategic point that this community will have to take. Who is it that we are going to serve? If you're going to serve the agricultural and small-term community, there are a different kind of partnerships that IITM and this group will have to form, which will have to go along the lines of what Dr. Premnath mentioned, getting into the context of commercialization and getting into that thing. It is an important area, but not necessarily something IITM can do well. IITM is known for its monsoon and climate work. If that becomes the domain where it can make a contribution, and then use it as a basis for evaluating science in the context of how climate models are reproducing this, how climate models or weather models can improve on that. Then there is a framework by which it can cascade for the wider scientific community. Having said that, I would say the point that the sensor being a 300 to 1000 rupee makes value when you're doing it for large scale application, and they have to have a very good qualitative sense. If you're developing research grade robust methods, then you're going to be more expensive, lesser quantity, but define what is going to be the metric by which you will say this was a success.
Yeah.
And once that is defined, the rest is easy. And I
Great.
wish all the best to this endeavor. And this is a fantastic opportunity, and more power to it. Look forward to seeing the success. Thank you.
Thank you. Thank you so much, Professor Dev. Dr. R.R. Mali, please. Dr. Mali.
Yeah. Good evening and good morning. Thank you that you have invited me. Thank you, everyone. First of all, as a concluding comment, I just say we must define the application for the measurement of this soil moisture measurement. I mean, we must define. If it is for the agriculture, let us work it on. If it is for hydrology, let us work on that particular. Because there are different models, different input that can be ingested to these models. As Dev Nyogi has already said, that sensor design, it should be robust enough to sustain for the extreme events, and also the local issues such as cutting of the cables, the usage of battery. Battery should have the solar powers. It should have the advanced technology, so that uninterrupted, seamless data should be available at even sub-hour intervals. Third point, I would like to say that we must install this sensor on an experimental basis at a different crop fields. I mean, that is what I feel. For different crop field, the requirement of the soil moisture and soil temperature, that is to be checked, confirmed, and it should be for the not only different crops, but for the different soils. They are getting watered through different resources, like we have sometimes irrigations due to river water, canal water, or sometimes the sprinklers. Sometimes there are many ways of getting even natural rainfall. So for the sensors to be installed under those conditions and analyze them, and get them the correct values as an experimental model. And once that is been analyzed, I think similar such things can be applied pan India. And these are all some of the inputs for the this discussion. And definitely I would like to be associated, be a part of this particular program in any way. If I can help and contribute, I'll be there always. Thank you so much for inviting Dr. Milind.
Thank you, Dr. Mali. Now we'll move to Dr. Premnath Venugopalan. Yes, sir. Please, sir.
Yeah, I'll keep it brief. I do understand the great value that this whole field brings. Very often when IITM is looking at it, you're looking at much larger scales and timelines, right? And since the time scales, the dimensional scales are much larger, and that has value in its own place. On the other hand, when a farmer is looking at it, his immediate concerns are important, but both are important because maybe a small sensors based system in a local farm creates a solution for his immediate concerns and immediate plans, but your predictions over a period of time, which might make a bigger difference and sudden catastrophic impact on his crop, is also very, very important. So I think what IITM can consider doing, in my opinion, is, see, we are not research organizations and not-for-profit organizations, which I think should contribute more to ecosystem creation. There will always be players who can deliver the goods at the downstream, and they will be private players and startups and small companies and so on and so forth, who will put all that to use. The question is, how can we enrich the ecosystem as IITM? And in one direction, of course, is sensor technology. What you might, your sophisticated systems might create challenges which might actually improve the quality of something which is less sophisticated as well. So I see an opportunity there. I remember one of our startups being asked, can you do this in 2,000 rupees, when we were looking at irrigation systems and so on and so forth. And clearly it is something which we have to head towards one day, but it's not going to happen immediately. The other thing is data. Many of our startups are trying to set up their own little weather stations and all of those things and do what is necessary to solve the problem, right? And I think it's important that data is made more accessible, more robust, simple to access, and it should be open access in many different ways. I've also looked at this also for air pollution, by the way. I do wish your data is a little more granular and easily available. So if those kind of things, that is ecosystem contributions and public goods, are made a little more accessible by national labs, I think the others putting it to use, people will do, and you'll automatically end up in agricultural outcomes and so on and so forth over a period of time. So I think I'll stop here.
Great. Thank you so much. So kind of you. It's a very, really important. And yes, we have to have the balance between R&D and applications. Definitely. Thank you so much. Now, next we will go to Professor Chopde, sir. I think, integrating the academia is very important in this. There is a say, if we want to go along, we have to go together. If we want to go fast, we can go alone. So we would like to hear from Professor Chopde, sir.
Yes, sir. Thank you. After listening the discussion, many things actually I got through this, and I remember the involvement of my faculty will definitely help to give the solution. Specifically to mention, say, design of the sensors, cost-effective sensors, and then the battery management system, so that the backup will be much larger. Then wireless sensor networks, then signal sensing and signal conditioning, because the signal level that is obtained from the sensor is very, very low. So conditioning is required. So amplification, then processing, signal processing. So definitely we can help in setting up all these systems. Then DAC and processing systems. So definitely we will be feeling proud to join the hands with IITM, and we will work in collaboration. Just I wanted to add one point I missed. We have more than 200 patents filed by our students and faculty together, where those are the design patents with Government of India, Government of Australia, and some PCP, which is applicable in Asia, these European countries as well. So many patents are interdisciplinary, supporting the interdisciplinary, where some sensor-based designs were also there. I will definitely expect, right? In between, some noise is there. I don't. Yeah. So to just conclude, joining the hands along with my student teams and faculty, to work on the interdisciplinary area. Agroelectronics I can again mention, or instrumentation. Definitely we will reach to some solution level and solve the problems of the society. Thank you.
Thank you so much, sir. This is what is government's policy also. I think we are following on the right track, but we have to have a good balance also. That's true.
Certainly.
Sir, lastly, Professor Dr. Shantanu Pendarkar, sir. Yes.
Sir, we are very much delighted to interact with you all in this brainstorming session, and we are pleased to get involved at all levels, whatever the capabilities we have. We are really enriched by the views expressed by each one of you from the different domains, and you gave us a great insight and work further in this domain with you. Thank you, Dr. Muzumdar sir and Director sir Krishnan sir, for inviting us. It's really great to listen views of Dr. Professor Dev and Dr. Franz, in spite of the odd timings for them. And it's really great.
Yes, we will give Professor Dev coffee. Nice coffee.
Yeah, next time, yes, sure.
नाही येतो मी चहाच घ्यायला येतो.
And we also look forward. We look forward for France also. We plan to invite him. Yes.
Yeah.
Pendarkar sir, the team can join.
तुम्ही पण यायचंय. आम्ही तुमच्याकडे येतो ना आता बघा पुढच्या आठवड्यात येतोच आहे.
सर नक्की या, मोस्ट वेलकम.
माळी सर
पुणेरी आमंत्रण देऊ नका तुम्ही लोक. कोण कोणाकडे येते कळत नाहीये. मला कोण बोलवते ते सांगा.
मला सगळेच बोलवणार.
Yes, certainly I will join. Thank you, Dr. Pendarkar sir.
Please sir, आपण आपली तब्येत ठीक आहे ना?
Okay, ठीक आहे आता. Now it's okay.
So we'll conclude with this, and final remark by Dr. Krishnan, and then I will thank finally. Sir.
Yeah. So dear Milind and dear all participants, thank you very much for, I really enjoyed today's conversation, and it was very good discussion. Actually, we have to, how we want to, it all depends on the purpose, how we want to, what application we are going to do, and how we are going to coordinate among the different partnering centers, that we need to really think. And thanks to all of you for providing very valuable suggestions, and especially Dr. Trenton Franz. Sorry to wake you up very early morning, and also Professor Dev Niyogi. And despite this very odd timing, you have really, with great enthusiasm, you have participated and provided your suggestions. And we will see how to put all this together into a kind of document, and we'll see how to go in the future. And it was very useful discussion. Thank you all once again.
Thank you so much. Thank you so much, Padmakar, the computer expert, our computer supporter. Please take a screenshot. Everybody can open the camera and we can have the screenshot. Padmakar, you are there? Yeah. So please, Padmakar sir, please take a screenshot. Yes. Let everybody may appear. Yes. Yes. There. Yeah. He's there. Yes.
Thank you.
Yes. Thank you. Please take a place. Yes. Padmakar, once you are done, please tell us. Thank you so much.
Thank you.
So, as the final,
Thank you. Have a nice day.
thank you so much for attending this brainstorming session as a part of India International Science Festival IISF 2021 outreach event on soil moisture monitoring in India, challenges and opportunity. I thank each and every heartfelt thank to each and every panelist, Dr. Krishnan, everyone. I think we will have much more opportunities to interact and do wonderful job to keep a balance between research and applications. Thank you so much.
Thank you, sir.
Thank you all. Thank you so much.
Nice to meet you.